Hello and welcome to another edition of OAuth Happy Hour. I'm Aaron Parecki and I got Micah Silverman here as well.
Hey everybody.
We are here to answer all your OAuth questions and chat about what's going on in the world of OAuth. A couple of new fun developments in the last couple of weeks. And yeah, we'll just get right to it. Go ahead and say hi in the chat if you're watching this live. So yeah, where should we start, Micah? Do you want to start with talking about the latest draft of 2.1 that I've been working on?
Absolutely. I've been a little out of the loop on the mailing list there, so I'd love to hear about it.
Yeah, well, not too much has gone on the mailing list at the moment because we have been sort of the three authors, myself being one of them, have been working on incorporating the feedback from the last round of discussions. So we've been working on um, talking amongst ourselves, figuring out how we're going to what we're going to put in the document so that we can actually go back to the group and say, um, here's the draft that we have come up with thanks to the discussions that have happened on the list and on the calls. So there's a couple things that have been going on in that, and I think we've covered some of them in some of these past live streams because these the last meeting about this with the larger group was several weeks ago now. Um, but we are finally we've been trying to work towards getting it to a point where we can where we all feel comfortable with it and can actually propose it to the group to be adopted by the working group. Because right now it's still just an individual draft, which means it has no official standing anywhere. Um, there's just our three names on it, myself and Dick Hart and Torsten Lauterstedt, and it's just an individual draft. So we're ready now at this point to bring it to the group. We just talked about it this morning, and we are ready to bring this version of it to the group to call for adoption, and then it'll become an OAuth working group item. So the this is I guess this will be a sneak peek of that because this is not published yet at all. It is still in my computer as a text file. I'm looking for that window, this one. So this is the latest version, and there's not a ton of differences compared to like where we were at a week or two ago. Um, but the one of the significant things that's probably going to require some explanation is this part. So this is interesting because we realized that so OAuth 2.0 defines two client types. It defines confidential clients and public clients. Traditionally, confidential clients are ones that have a secret. So we've got server-side apps, so your Java, .NET, whatever, right? You can put API keys in those, and it'll stay secret. However, you can't deploy API keys to JavaScript apps or mobile apps, which is a problem, and it's one of the reasons that PKCE was developed, was to be able to not need to use a client secret to provide that security. Um, and those are considered public clients. So public clients are clients without credentials, public clients. However, something has sort of been happening slowly over time and is in some cases, how some of these systems work, which is using dynamic client registration. So that's the idea where instead of like the developer going to the developer site of service and logging in and then going and making an app, instead, there is an API to register clients. So the app itself, the first time it boots up, will say, well, I don't have any API keys that were in the deploy, and I don't want to be considered a public client. So I'm going to go use a dynamic client registration to register my information, like redirect URLs and the logo and things like that. And then it'll get back a client ID and a client secret. So at that point, for most of the rest of how OAuth works, that can be considered a confidential client. However, it's not really a confidential client because there's something key that's missing about that, which is the identity of that app is not confirmed, right? So it turns out that a client secret does two things. One of which is confirming the identity of the app. The other is using that secret to protect a lot of the rest of the flow. So this sort of dynamic client registration, an app created using dynamic client registration is not there is no confirmation of identity most of the time. So it's not really confidential, and that's why we have this new term for it, which this is not by any means set in stone. Again, this is an individual draft. This is just some stuff that have come from some people's heads, but this is a term we came up with that we're going to propose, which is credentialed client. And it's a client that has credentials, but the identity has not been confirmed. So that's a distinguishing factor there.
I have questions.
Yes.
So did this come out of somebody's experience or something that's out there, like an API for registering a client that people have encountered?
Yeah.
Something that if I were so inclined, I could go wrap my arms around and play with, for instance.
Yeah. So this spec, RFC 7591, is
Ah,
dynamic client registration. And this talks about, it's essentially an API for registering clients. So here's a client registration endpoint, and the request that it makes is this. So there's a registration endpoint, and then it'll post its redirect URLs, client name, how it intends to authenticate, logo, optionally keys, and then it'll get back. These are different kinds of registration requests. Here is the response. So here's an example response. Client ID, client secret, and then blah, 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 right? So this exists, and a lot of services support it. I actually don't know off the top of my head any that we could like try right now.
right.
But this is an RFC. It is supported by several authorization servers,
Hmm.
at the very least. So, yeah, when that happens, if there is no authentication provided in that request, like if you're a mobile app, you can't ship credentials ahead of time, so the mobile app can just boot up, register itself, and get a per instance client secret, which is not confirming the identity of the app because anybody can mimic that API call, right?
And that was going to be my next question. So is the intention of this dynamic client registration kind of like a one-time use thing or a limited use thing? So the next time I go into the app, it would go through that registration process again in order to be able to do an OAuth flow for that session, or is it more persistent than that?
No, it's more persistent. It's meant to be like the first time that you download the iPhone app registers itself, and then it gets a client ID and client secret that represents that instance of the app install. And if
But
you
yeah, I was just
so if
gonna
you
say
deleted the app,
that's kind of cool because it's almost like the notion of having keys that never leave the device. So
yeah,
now you
that's
have
that's
this
the real
app and
benefit
yeah,
is that you can use a lot of the security properties of a client secret in a mobile app environment because um, those keys are only ever sent down the wire once from the authorization server during the registration step, of course, over HTTPS. And then the app can keep it, can store it securely. And there's certainly on mobile platforms very good cross app isolation. So it's not really a concern about it leaking. Um, but it doesn't say anything about the identity of that app, right? Because if this registration endpoint, where's the one without a key? So like here, um, this is a unauthenticated API request because it has to be if you're doing it from public client or from what previously we would have considered to be a public client, right? A mobile app or a JavaScript app. Then anybody can make this request. You could just mimic this. You could, figure out what the real app is doing when it registers itself, and then just make a request that looks just like that and get a client ID, client secret, and then, you put whatever name you want in here. You could put the real app's name in this request, and you would get a client secret, which would look like the real app. So the reason this is important, and the reason this idea of confirming the identity of the app is important, is because there already have been places in OAuth. I might have to dig up the references, but there's several places that talk about what authorization servers should do depending on how much it trusts the identity of the client. So mainly around the idea of consent, right? So if when you for the very first time use your Google account to connect to some other service, you're going to see that prompt that's like, hey, this app is trying to request this data from your Google account. Do you want to allow it? And then you click yes, and everything is happy. And then you come back a week later and you go to that same app and you log in again, and it doesn't show you that prompt again, right? Because it wants to just get you right in. So the reason it can skip the prompt is because the identity of the app is confirmed if it's a confidential client, because it has a client secret, and Google knows that nobody else can fake that request, right? It knows that it's only the legitimate application that it's going to bypass the consent screen for when it returns. So that's fine. Now, if you're talking about this new middle tier of credentialed client, you can't bypass the consent screen when the user returns safely, because anybody could mimic that request and trick the user into immediately getting redirected without a prompt to the attacker's app. And that's been described in OAuth for a long time, actually. It's just that we never had a word to concisely sum up that idea. So I should have dug up the references on this. But I think if I go to, it's either in core or it's in security best practice or it's in native apps. So
It's not a huge set
of yeah. Speaking of OAuth 2.1, yeah. So I might have to dig this up in a little bit. Yeah, it's probably in security best current practice. But yeah, let's take a look at the chat.
Any
questions about this credentialed client type?
Yes.
So how is the idea of the identity has been confirmed by the AS defined? That's a good question, and we might need to clarify that in the spec. But the idea is that the authorization server knows what actual app it is, like the fact that it's been registered sort of ahead of any of the OAuth flows starting. So if I'm the authorization server and I'm about to send a user back to the app, I want to make sure that I'm sending them to the real application, right? I want to make sure that I'm sending them to the legitimate, US Bank app on my iPhone or the legitimate Twitter website. So that's the identity has been confirmed. It's the authorization server knows where they're about to send the user to and can confirm it, and can confirm that the request that was made for that redirect is from the real application. So basically that it can't be faked. So an unconfirmed an app without a confirmed identity would be something where on that consent screen, if it just says Google Docs is trying to, or yeah, this was the Gmail hack a while ago. Not hack, worm, and this was where the Google consent screen. Okay, I found it. That was pretty quick. Shows this. Google Docs would like to, right? And this text Google Docs is just something that somebody typed in, and this is not the real Google Docs client ID. So this is an example of like why this is important and why you need this consent screen in here. So an app without a confirmed identity is something that would be fakeable. Anybody could mimic that request. If that makes sense.
So in the current state of affairs, if I were attempting to represent myself as a confirmed confidential client, I might know the client ID, but it would fail pretty quick because I wouldn't have a redirect URI that would work. Like I could try to get them to redirect.
And you wouldn't have a client secret, more importantly. You wouldn't have
right. I would
corresponding client secret for that client ID.
Yeah. It raises some interesting questions because in Okta, we have an applications API, and you can go and use that API to create confidential OAuth clients.
That API is authenticated, though.
Yeah, that's right. You need to have an API token from Okta in order to do that. So even though it's an API, it's still a confirmed identity.
Yeah, the assumption is that the Okta admin is not going to hand out the API keys that can use that creation API just to anybody.
Fingers crossed.
Fingers crossed. Yeah. But yeah, so that's the idea. So yeah, I guess Okta. Do you know if it is the dynamic client registration protocol or is it its own?
No, it's Okta's apps API.
It's one of the okay, yeah.
Yeah.
I actually don't know if the Okta API supports dynamic client registration at all.
Yeah, I don't either. I know Okta's proprietary apps API has a type for OAuth, and you can go and create a confidential client and get back a client ID in secret. But that's Okta's thing.
Yeah, yeah. Yeah, okay, so then there's another question. Couldn't this credential be somehow combined with the idea of IndieAuth to verify the identity? For example, the authorization server could go off the controlled domain for double checking the redirect URL, etc. Yeah, so in IndieAuth, there is no registration step for clients because every client is identified by its URL, which is a form of confirmation of the app's identity. And so the client ID is the app's URL, and then at that URL, you can discover the name and the logo and the redirect URLs of that app. So that is a form of identity verification of the app because you're using just the client ID to fetch the name of the app, which means it can't be faked, right? Because if I used a different client ID, it would like if an attacker created a client ID, they wouldn't be able to also then like control the redirect URL of the real app, and it's a form of identity assurance of the app. But yeah, in IndieAuth, there's no registration steps. There's no client secrets at all because for the most part, there is no way to register those clients ahead of time anyway. And doing a dynamic client registration to get a client secret doesn't make it an identity, doesn't confirm the identity either. So that's why we went with the client ID being the URL.
I have a follow-up question, and it's possible this will put you on the spot, so I apologize in advance. But my understanding of part of the main motivation of OAuth 2.1 was to kind of, pare down what's already in OAuth 2.0. So how did you get to the point of saying like how did this idea of a credentialed client type like bubble to the surface as being important to include in this revision?
That is a good question. So let me, so the short answer is if you look at all of the specs in OAuth 2 that we are consolidating into this one document, there are places in those specs that talk about the idea uh, of a client that has a client secret that is not actually where the identity isn't actually confirmed. Like it's kind of like that concept is described in several places, and it's kind of wordy because it has to caveat. It has to be like a confidential client, but whose identity is not confirmed, or a public client that has a client secret, which neither of those really make a lot of sense. So
Right.
there already was this sort of dancing around these terms in the specs, and the idea is to use a term to a new term to more quickly describe that when it's used in the specs. Um, so I found so there's a place in the spec where this is actually used. This is later down in the draft after we've defined, the different client types. Then it talks about client identifiers, and then it talks about client authentication. So if the client is confidential, then blah blah blah. Authorization servers should use client authentication if possible. And then this is a text from some other spec. If I search for this, it might show up. Um, it's oh wow, it's just copied into a lot of. Oh, it's from the core. Okay. I forgot where we've been pulling in so many different things that I forgot where it came from. But this is RFC 6749, right? So it says the authorization server may establish client authentication method with public clients. However, it must not rely on this authentication for the purpose of identifying the client. So it was already in the core. And then it's referenced later of like, when you're talking about the consent screen and whether to bypass it upon returning and things like that, this gets to be important. So what we're doing is we're changing that paragraph to the AS may establish client authentication with public clients, which converts them to credentialed clients. And then it's the authorization server must not rely on credentialed client authentication for the purpose of identifying the client. And the idea is that this is hopefully a little bit clearer and gives us a term that can express both having a client secret, but not having confirmed the identity elsewhere in the drafts as well as in extensions in the future.
Right. And I think you just answered my next question, which is it sounds like if I want to be OAuth 2.1 compliant, I don't have to implement dynamic client registration.
Oh,
But if I do, I have to make sure that I'm not relying um, on that client secret as an authentication for the client. Is that right?
uh, almost, yeah. So you definitely don't have to implement dynamic client registration. We're not actually pulling dynamic client registration into 2.1. It's still an extension. And there's still a lot in 2.1 that's optional as well. So it's not like you have to do everything in the spec. But if you do use dynamic client registration, then that without authentication, like if the registration call does not require authentication, then that client would be considered a credentialed client for the purposes of reading the rest of this document. So then when talking about the different ways that app interacts with various things later, it is then considered a credentialed client, and that's what you'd be following. Those are the recommendations you'd be following for that dynamically registered client.
Got it.
Yeah.
Cool. New client
Yeah.
type. I like it.
Yeah.
Disambiguates
Hopefully,
stuff that's already been talked about.
hopefully it clears things up. Um, ultimately, I don't actually like the terms confidential and public clients either. I don't think those are actually very descriptive, um, especially especially the fact that confidential is now more about the identity being confirmed because the other two clients do not have their identity confirmed. So it would be nice to have a term that better described the fact that it's actually the identity that's being confirmed by using some sort of, client credentials. Um, and then public clients also don't really make sense because what does public mean? Because in, public confidential clients, like a client, an app with a client secret running on a server might still be publicly accessible, right? It's not like it's locked down to be only accessible by certain people, which is kind of what public sounds like the opposite of to me. So I don't really like those terms, and I would prefer to have new terms that are more descriptive because this is like one of the first things you have to describe about OAuth when you're talking about it, right? And it's like, thanks for all this, jargon that you made me explain. Um, but that changing those terms would probably be more confusing than helpful at this point, because even though there would be no behavior change if we just change the terms, we wouldn't be changing the behavior of anything in the spec. It would still probably be too confusing to do that in 2.1.
Yeah,
So
people are very socialized to those terms at this point, developers,
yeah,
providers. Can
a
I
lot
ask
of
one more
documentation
to
would have
that
to
one
get updated.
question?
Yeah, totally.
Yeah. Um, has anything evolved based on the previous conversations with regard to the PKCE language, like for confidential clients or using PKCE in general?
Yep. Yeah, totally. That was one of the other big changes we did here. So that would be in, share my screen again. That would be in authorization code grant. This is a text one, so it's not clickable. Um, so here, what we've done is we've described. So here's authorization request. If you look at RFC 6749, the authorization request starts with create the request URL, right?
Hmm.
Add these parameters. And now what we've done is we've said, do PKCE. We haven't called it PKCE. We're just describing the mechanism.
Right.
Um, and then we say, by the way, this is, from PKCE. Um, but here is the new text. This is, again, of course, not finalized, caveat. And this
Mm.
is now what we have given the discussions on the list. This is what the authors have determined is an appropriate way to resolve all of the concerns. And we are now going to bring this to the group and see if everybody else agrees. So this is not yet agreed upon. But here's what we're
Right.
proposing. Clients must use code challenge and code verifier, and authorization servers must enforce their use, except under the conditions described in section 9.8.
And
But even then,
is that
they're still recommended. Okay, so
nice?
that's how we've decided to carve out the one exception. And then it just goes on to talk about how to do PKCE, right? How to
Right.
use those parameters. Um,
And
and
does
then
section
again, it
9.8 talk about
says
the nonce exception?
exactly.
Yeah.
So section
Oh,
9.8
yeah, I see.
talks about. So section 9, first of all, is the I should have had the HTML version up. Section 9 is security considerations. So this is where it starts going into detail about particular situations and like particular attacks and particular recommendations to solve those. So 9.8 talks about authorization codes. So this is from the core of like, you have to send this over TLS with redirect URLs and must be short-lived and single use. And then here, this is the new stuff. So clients must prevent injection of authorization codes. That's the must. And um, to do this, code challenge and code verifier will protect against injection of authorization codes. And you have to do it unless both of these are true. One, it's a confidential client, although I think we might need to revise that to be credentialed, include credentialed now. Yes, because it's a use of a client secret. So a credentialed client would
Yeah.
be a use of a client secret that would prevent this. So I'm going to add that. And so yeah, basically if it has a client secret and in the specific deployment and for this specific request, there's reasonable assurance by on the authorization server that the client implements the OpenID Connect nonce mechanism properly. So that is the carve out for OpenID Connect public or confidential clients. Public clients have to use PKCE, even if they're doing OpenID Connect. Confidential clients that are using the nonce parameter do not have to do PKCE. And that is there just because there are deployed systems that are secure against code injection attacks that are doing it, that are plugging that hole via the nonce parameter. Right. I don't like this suggestion of using this because it's very complicated to explain and it relies on the client developer doing it right. And the authorization server can't tell if the client developer has done it right.
Yeah,
So
reasonable assurance is hard to come by.
there's basically it's you have to audit the code. You have to audit the client, right? So a authorization server that's serving the general public, like Google or GitHub or any of those sort of public authorization servers that anybody can show up and just write an OAuth client, there is no possible way that those authorization servers can have a reasonable assurance that a client is using the nonce parameter properly, right? Because they have no reason to trust those developers. Now, if you're in a company and you are working closely with the developers of your applications, you can ask them, look at the code, and audit your applications and make sure that they are using the nonce parameter properly. And that's the reasonable assurance this is allowing. But yeah, so we went through a couple of iterations of how to phrase this, and hopefully the group agrees that this is a good way to handle it. The goal was to allow that exception, and I feel like it does allow the exception while also not promoting it, because I don't want developers to look at this and be like, oh, cool, I can just not do PKCE, right? Because if you don't do PKCE, you actually have to do a lot more. In order to use the
Right.
nonce parameter, you have to is several more steps in order to actually do that right. So
Yeah, I think it makes it clear that, at least to me, reading it, that like I would be left with, you know what? I'm just going to use PKCE because it looks a lot harder to even try not to. Even if I already have OpenID Connect in the mix, why not make it easier to just use PKCE?
yep, and especially because it'll error out faster in a more secure way if there is an attack.
Yeah. And especially if I'm the Googles or the GitHubs of the world, I don't have to rely on
Yeah.
individual developers' approaches. I have a higher degree of assurance.
Yep. So I saw a
Got a
question
couple questions
about
in the hopper.
so dynamic client registration. Is it used for identifying individual installs of a certain app on different phones? For example, if I have two Android phones with the same app installed, they'll actually use two different clients for the same AS. Yeah, so the idea with dynamic client registration is it would, if you have two different phones, each would make their own registration call because there's no data share between the phones, and they would get different client IDs and client secrets in response. They would both push the same app name and probably redirect URL and app logo. They would push all of the same information up in the registration call, but they would be getting different client IDs and client secrets in the response. So so one authorization server would then have a whole bunch of client registrations for every install of the application, right? Um, which makes sense in some situations and obviously doesn't make sense in others. Um, so, yeah, that's the idea there.
Is there a reasonable SPA use case for a credentialed client? Doesn't seem
That's a
like
good
there would be
question.
because you have to store that client secret somewhere. The same way, if you get a token, you have to store it somewhere. And that could
Yeah.
be worse than a token because if some malicious app gets a hold of it because you put it in local storage or something, now they have a client ID and a client secret and can just go up and mint tokens, right?
Well, you still have to get a user involved, right? You still have to like
Yeah.
get a user to log in. But yeah, it could now impersonate the single page app easier, even easier. Um, I feel like I should make a note of this because that's actually probably worth talking about, like talking about in the spec, which is that um, it's only useful to have a credentialed client if the client is reasonably sure it can hold the credentials safely, which I feel like is sort of mentioned um, in here. Yeah, well, it's any clients with credentials must take precautions to prevent leakage and abuse of their credentials. And there isn't really a reasonable mechanism to do that in a single page app environment. Um, so it's probably not a good idea to use credentialed clients for single page apps. You might as well just treat them as public clients. I
Right.
feel like it's more useful for mobile apps because there are much more secure storage options available on mobile, and it's useful in like um, maybe if your cloud environment is spinning up a bunch of servers and they register for credentials when they first boot up, um, instead of using like a common key store or something. Yeah. So yeah, interesting stuff. Trying to think if there was anything else significant in that update, um, in those changes we've been pushing. Um, oh, refresh tokens. That was another discussion on the list, which was there's some concern about actually requiring one-time use refresh tokens. So and this is probably going to affect the security best current practice too, to have this advice ported back into there. But the concern is that so the uh, oh my gosh, I was completely blanking. Refresh tokens. Okay.
Yeah.
um,
Requiring new refresh tokens every time.
yeah. So with a client secret, you don't need to worry about it because assuming the app keeps the client secret, a refresh token getting leaked can't be used by an attacker. So that's fine. For public clients, if there is no client secret, and it's specifically public clients in this case, not credentialed, if there is no client secret, then a refresh token is all you need in order to get new tokens. So if a client secret or if a refresh token leaks and there's no client secret, then the attacker can start using that refresh token to get new access tokens, and the legitimate app would also be using that refresh token to get new tokens. And if it's the same refresh token, if it just sticks around and is usable for whatever the lifetime of that refresh token is, which is probably very often unlimited, then now you've got an attacker able to get real access tokens whenever they want because they've got the refresh token. And there's no way to detect this either because there's no client secret. So that's the problem with public clients using refresh tokens. And because JavaScript apps are such high risk, it's generally not, we don't give JavaScript apps refresh tokens at all because it's too risky. And you'll see this in Okta if you go make a single page app. First of all, you don't get a client secret, but second of all, you can't even turn on the refresh token grant type for that client, right? And one way to protect against this is to have the refresh tokens be one-time use, so that you would get a refresh token, access token pair, use the access token until it expires, use the refresh token to get a new access token, and you would get back a new refresh token, and then you just keep, it's pretty straightforward if you are sort of in the simple case of, you have a clean code path and not a lot of complicated architecture here. So that's all fine. What this does is it means that if that refresh token is leaked, then, and the attacker uses it, the real app wouldn't know that it's been used already. It would try to use it, and the authorization server would say, oh, I see it's already been used, so I'm going to reject the second request and deactivate any future access tokens and any future refresh tokens, kind of stopping that attack, right? And that's nice and secure from the authorization server's point of view, because it can now detect whether a refresh token has been stolen, whereas before it couldn't. So that was the idea. The problem is that in certain deployments, this is actually impractical. And the particular deployments where this is impractical is when, so it could happen both in single page apps as well as mobile apps. The idea is that if you have a lot of parallel things happening at once, then you may not actually be funneling all of your API requests through a central sort of queue. So you might have a user interaction on the page triggering some requests with an access token. You might also have some sort of background process on the page that's doing it on its own schedule. Now, if those happen to take place at roughly the same time, where the user clicks something and then also like this background task goes and makes a request, and this API request comes back with a new refresh token, but then this one sees that it expired and tries to use that refresh token as well, there's this race condition where you might end up with two different pieces of your application trying to use the same refresh token at around the same time, which would then look like an attack, and the authorization server would log you out. So the only solution to that, if you actually wanted one-time use refresh tokens, is to sort of make a API request queue that everything in your app funnels through, so that the different components don't make API requests directly. They tell the queue to make the request, and then that is the one that's like, oh, I see the access token's about to expire. Let me pause the queue, go deal with the refresh token, and then resume the queue. And that's difficult, and sometimes very difficult to actually implement in an application. Like on mobile, for example, these are happening in different threads, and there's not necessarily even a way to communicate across threads, so it can just not really be practical. So we decided to not require one-time use refresh tokens in that case. It's now just a should, which is, I guess, reasonable. I'm always sad about putting shoulds into specs because it's giving people options and a way out of doing something that's a good idea.
Is there anything in the go ahead.
Should means you must do it unless you have a good reason not to. That's what it means, right? So a good reason not to would be that you have this architecture where it's impractical and you're okay with the risk. So
is there anything in the security section that speaks to that situation where you could run into trouble if if I'm a new provider and I want to support OAuth 2.1 and I want to support a new refresh token? Is there anything that kind of lets me know that it could be problematic under certain situations where it could look like an attack but it's not really an attack? if the client or if the application isn't architected properly.
I don't know if it actually mentions that now that you say that. Um, do you think that would be useful to actually mention in the spec?
I mean, I may not be representative. I'm just thinking of myself as a developer. I would want to. I've been waiting and wanting to use, unique refresh tokens, but then you described a whole scenario that I would have to make sure my app handled properly if there was a lot of parallelism, if I wanted to support that. So it might
Right.
be useful to mention that somewhere,
Yeah.
especially since that's the
So
only reason it turned from a must into a should, right?
that is a very good point. Yep, that is a good point. I'm gonna have to watch this video back in order to remind myself of all these notes that I want to add.
Yeah,
But this is like this is actually a good reason that these discussions are helpful because like this is how the specs get written. So here is
yeah.
the section on refresh token protection. This is the thing that became a should. So authorization servers should use one of these methods to detect refresh token replay. Sender constrained refresh tokens. This is a any of the possible, these are still drafts, that's why there's no RFC, but any of the possible methods of binding cryptographic keys to refresh tokens. Um, None of these, this is the only RFC out of these three options. These are still very much in the works. I would not consider them stable or well tested yet. So this is kind of a early, it's earlier than would normally be. It's earlier to recommend this than would normally be in a spec. Um, but at least one of them is an RFC. It's a little bit premature to actually say you should do this right now. So the other option though is refresh token rotation, which is very easy to support on the authorization server side. Um, so I shouldn't say very easy, but it's a lot more straightforward. So new refresh token on each response. Um, this describes the attack. However, I don't think this talks about um, a scenario, this scenario from the client side. So I should add that to. It's probably worth adding that. Um, so add description of parallelization of or problems of parallelization of requests with refresh token. Okay, that's what I'm going to do. Thanks for that idea. Um, Looking at the questions again. So here's one. Is the 9.8 exclusion for PKCE final, or can this still be revised? PKCE doesn't seem that hard to implement on the AS, and the exclusion pollutes the simplicity of the spec. Yeah, that's why I'm not happy about the exclusion. Um, First of all, though, to answer the question, the first part of the question, this is absolutely not final whatsoever in any way. This is not even adopted by the working group yet. So this is just something that at least three people agree on, and we will be taking it to the group soon. Um, and then it'll become a working group item, which means it has more people who agree on it, basically. But yeah, this is definitely not final. However, there was a long discussion on the mailing list about this particular item. And originally we had not had the exclusion in the draft, and it was essentially made very clear by some vocal people that they would not support adopting the document unless it had this exclusion. And the reason for that is because this the mechanism of PKCE, what it's doing is preventing authorization code injection. There are multiple ways to prevent authorization code injection, which means if you have implemented OpenID Connect properly, and you can be sure you have, you aren't vulnerable to authorization code injection. And so it is still a secure system, which means you gain very little by adding PKCE. And there are lots of deployed systems that fall into that category of they're OpenID Connect, they are not doing PKCE, and they're still secure. So the problem was that we don't want OAuth 2.1 to come out and then have that suddenly make it look like those apps are not secure. That was a concern. So what we tried to do very carefully is word it so that the exclusion is very specific, and it's not a general exclusion to say, because I think one of the earlier versions of the text had something like clients must prevent authorization code injection. Here's one way to do it, which is like too vague, right? So we want to say do PKCE because it prevents authorization code injection. However, if you prevent this in this specific way using OpenID Connect and Nonce, then you don't need to do PKCE. And yeah, it is a little bit annoying to have that exception in there, but I feel like I'm okay with that if that lets us move forward with the rest of it. But yeah, it's not final, and will probably still be talked about, even though there's already been a round of discussions on this particular point. It'll probably have another round of discussions on it again once we actually bring this into the group. There was another question here, which I'm trying to remember what this was when we were talking about, I believe,
Dynamic client registration.
Yeah, so it's repeating the functionality provided by cookie session IDs. What are the main benefits of client registration be instead of those? I guess it's serving a different purpose because, again, one of the things dynamic client registration does is it pushes the app's config, like the name of the app and the logo, up to the AS at that registration point. And those are the things that are used on the consent screen. And that has nothing to do with cookies, right? Like, there's no, those are completely different problems. So it pushes up the config of the app so that the authorization server can show the app's logo on the screen when the user tries to log in. If you don't have the consent screen enabled, then they're probably more similar in terms of what they're doing. Of like, it's just essentially then a mechanism to get a client specific string, which is basically what a session ID is. But yeah, it's more about being able to register the redirect URLs, for example, and the app config.
I also think, cookie session IDs, there's an expectation that that's going to expire at some point. This seems like a way to get a fixed client secret into an app that it can use indefinitely, in theory.
Yeah, definitely true. And yeah, cookie session IDs are likely to expire. The client secret that's dynamically registered is meant to be effectively permanent for that instance of the app. And then the other thing is session cookie IDs are, of course, a browser mechanism. So this dynamic client registration mechanism works in anything, not just browsers. So mobile apps or apps without a browser at all, like an Apple TV or an Internet of Things device.
Would it be odd for a provider to support both dynamic client registration and PKCE? And if not, what would the recommendation be if you have both available to you and I'm building a mobile app? Would you say one approach is still better than the other?
Yeah, so PKCE is, or rather, a client secret alone does not prevent authorization code injection, which is the demo that we talked about that you did a couple weeks ago. So client secret by itself doesn't actually prevent authorization code injection, which is why that carve out for OpenID Connect only applies to apps that also have a client secret. But you still have to do something to prevent authorization code injection. And PKCE happens to be a great way to do it. I wonder actually if Um, oh, wait a second. I just realized something
You may not be able
with
to
the,
add credentialed client to those two conditions, right?
well, no. So credentialed clients, if it's a per instance client secret, then the attack that we demonstrated of authorization code injection actually doesn't work. Because if every client has its own secret, you can't trick it into exchanging an authorization code from a different client,
Right.
right? It's only a problem um, when the app can be accessed by two users and the app has the same client secret. So like a web server app is running on a web server, but it can be accessed by multiple people. So the problem
Right.
is that you can swap those people's authorization codes, but it goes back into the same app that uses the same client secret. If we're talking about if we're talking about um, mobile apps that use dynamic client registration to get a per instance secret, then every user has their own secret, effectively, which means that you can no longer swap authorization codes across
Right.
those. Um, so
So in the
yeah,
case
that's interesting.
specifically of a mobile app, if you have both available to you, it doesn't seem like one is necessarily better than the other.
Yeah, if you have
Specifically in the case of mobile app.
specifically for mobile apps, this is an interesting question. Specifically for mobile apps, uh, well, if you think about what Pixie is doing, right? Pixie is actually um, effectively it's registering a client secret that the app makes up instead of that the AS makes up.
Right.
And the way it registers it is by sending a hash of that secret to the AS on the request.
Yeah.
So um, if it would first do dynamic client registration, then it makes a post request to get a client secret first, and then uh, that client secret would never be used by any other instance of that application. So it's effectively the same as the Pixie code verifier, right? Because the Pixie code verifier is made up by that app and never shared with anything else.
Right.
I would have to think through a little bit more about the implications of the dynamically registered client secret existing on like consecutive logins versus the Pixie code verifier is per login,
Always different.
right?
Right.
So
It seems pretty clear to me as a provider that there would be a lot more architecture and infrastructure to support dynamic client registration than for Pixie.
yeah,
Seems like a lot of extra effort that is already kind of handled by Pixie,
right. Yeah,
just off the
that's the other
top of
way to
my
look at
head.
it is if you imagine like going into your Okta dashboard and looking at your list of registered of applications, it's going to get real long, right? If you have dynamic client registration and you have like 10,000 users, now your list of applications is 10,000 long, and there's no real information in those except like maybe like when it was last used or whatever. Um,
Right.
so that's definitely messy. There's no way around it really. And because they would be unauthenticated registrations, um, you can't even really be sure that they're all legitimate. So you would, I guess, like probably in the UI, you'd probably group them by name or something and be like, there are 10,000 registrations of an app called, my mobile app, but of those 10,000 apps, you would have no idea which ones are legitimate or which ones were, faked. So that sounds messy, and Pixie solves the that problem of authorization code injection and per instance authentication effectively much simpler in a way that doesn't require all that UI to be built up around it.
Yeah. It kind of, I'm going to look more closely myself, but it leaves me with the question of in a world where Pixie exists, what is the important use case that dynamic client registration solves?
Yeah, that's the I mean off the top of my head, the thing that I would say is, um, and this is again the same thing that IndieAuth solves, just very different in a very different way. If you have a WordPress site where if a WordPress like open source project like WordPress, where there are many installs of it, and if it's its own OAuth server, then there are hundreds or thousands of authorization servers. And then you have iOS developers that are making mobile apps, and there's hundreds of those. They obviously can't have a relationship with all of them, right? So um, what dynamic client registration does that PKCE does not is it lets those apps show up without any prior relationship, registering its name and logo and redirect URLs with the AS because it may be used by many different ASs.
Got
So
it.
I think that's the specific thing that it's useful for. Um, but you're right, in like a more closed environment, I don't think it's useful. Of
Right.
like it's probably better and safer to require that the organization admin is the one that goes and adds applications and issues client IDs and client secrets so that they can have more of a control over what apps are accessing the system. Yeah.
Makes sense. Well, that brought
Well,
us to the
cool.
top of the hour. We thought we might talk about some other stuff. We didn't get to
Yeah, I
it.
guess we didn't even get
That's
to it,
good.
but that's great. That's great. Save it for next week. Speaking of,
Yeah.
how often are these live sessions? We are trying to do them weekly. We've slipped up a couple times last month, but this is the time that we are scheduled to do it, and we are trying to do them weekly. Hopefully, we'll be able to continue weekly. If not, if we miss another one or two in July, I think we'll probably switch to biweekly, just so that we don't keep psyching people out about whether it's happening. Um, but yeah, you can always find the next one on this YouTube channel, of course. So subscribe, and you'll see it at the top of this page, or it'll be on your home screen. Um, Give this video a thumbs up so that more people know that it's cool and to join. And we also have a website, oktadev.events. This will always show the latest events that are happening. So here we are, Happy Hour Live Q&A. You will find the next upcoming happy hour on this page as well. Speaking of, if you do have more OAuth questions, I am doing more workshops, as you can tell here. And these ones are open to the public. So this is part 3 of the series, but you're welcome to just jump in. And this is part 3 is talking about the APIs. So we're talking about securing APIs, dealing with access tokens, things like that. And lunch is on Okta. If you register, you will get a Grubhub gift card for the day of the event. So come and do this, and I will buy you lunch. I'm then doing another 3-part series the week after, and also a longer session all at once on the 15th. So you're welcome to join any of those. They are all free, and you will get lunch, or for this one, you'll actually get a copy of my book as well. So with that, I think we will end here. Thank you all for watching, and we will see you next time.
See ya.